Good morning, class. Today we are starting our Unit 3 and it's all about angle relationships. In this class, I am going to review adjacent, complementary, and supplementary angles, and then I will explain some of the new terms and different angle relationships, such as vertical, linear pair, transversal, interior and exterior region, alternate, consecutive, and corresponding angles. So here we go. The first term that I would like to review is adjacent angles. They are angles that are always side by side. They have to share a wall and a vertex. If you look at the example on the left side of the screen, those two angles COB and BOA, they are adjacent because they share a vertex and a side. But if you look at the three examples on the right, those three examples are not examples of adjacent angles. Look at the first counterexample. Do you see that they do not share a vertex? They break rule number 2. The second counterexample actually does not follow the definition of adjacent angles. They're not side by side. And the third example actually breaks rule number 1, which is to share a wall. The next term I would like to review is complementary angles. They are two angles that add up to 90 degrees. Those adjacent angles on the board are all complementary, so they can be 30 degrees and 60 degrees, they can be 55 and 35, and so on. Notice how they do not have to be 45 and 45 degrees. As long as they are adjacent angles and they add up to 90 degrees, great, we can call them complementary. And the last term that I would like to review is supplementary angles. They're also adjacent, but instead of adding up to 90, they will add up to 180 degrees. Again, it does not have to be perfectly cut in the middle, 90 and 90. It can be any other combination, such as 120 and 60, for example. So let's start talking about angle relationships then. The first one I would like to mention is vertical angles. All of those on the board represent vertical angles. If you notice, they're always on opposite sides of each other, and it is very important to know that they're always congruent. It does not matter how much the angle measures. The vertical angles will always be equal. So in this first example, if I told you that A measures 70 degrees, you can be sure that B will also measure 70 degrees. Linear pair angles are always side by side or on the same side of a line, and they always add up to 180. Now, many students ask me, can I just call it supplementary then? That's a very good question, but the term linear pair is classifying the angles by their relationship, and the term supplementary is classifying them by their measure. For example, imagine that I have a friend who's telling me a story and I do not know one of the guys in the story. I will ask, who is he? She can answer, the 6 feet guy. And I will say, oh, okay, I know him, I got it. Or she could say, Katie's brother. And I'll say, oh, all right, I know him. Just like she could classify the boy by his height measure or his relationship to someone else, I can classify those angles by their measure, supplementary, or by their relationship, linear pair. So we can actually use both terms. Transversal is the name we give to a line that cuts through two or more lines. The lines can be parallel or not, but if there is a line that cuts through them, we call that line transversal. Some angles will be classified regarding their position in relation to the transversal and the double lines. We will use terms such as interior and exterior. So if you look at this example, where would you say the interior region is? Some students have trouble with these terms since the image is not closed. But imagine that you're driving a car. Someone tells you, stay in your lane. A lane is not a closed shape, but you know you're supposed to stay in between or inside the double lanes. Therefore, the exterior region is the outside area of the double lines. I use very simple definitions here. Inside the double lines and outside the double lines. This information should be enough for us. Let's talk about alternate angles. Alternate means different or opposite. So when I talk about alternate angles, it means that they are on opposite sides of the transversal, not the double lines, the transversal. Look at the examples. One angle is to the right and the other is to the left of the transversal. In the middle of the slide, we have examples of alternate interior angles because they are on opposite sides of the transversal and inside the double lines at the same time. On the bottom, I have alternate exterior angles because they are on opposite sides of the transversal but outside the double lines. Consecutive angles are also called same-side angles. Actually, some teachers don't even use the term consecutive. I will always use both and accept both because they're equally used. There's not one that is more used than the other, so both are okay for me. And in this relationship, simply means that they will be on the same side of the transversal. Both angles will be on the right of the transversal, or both angles will be on the left of the transversal. On the left side of the screen, I have consecutive exterior angles, same side of the transversal, outside of the double lines. On the right side of the screen, I have consecutive interior angles, same side of the transversal, inside the double lines. And finally, our last relationship, corresponding angles. To explain corresponding angles, I would like to use a car analogy to help us. Imagine two cars in traffic side by side. Now imagine that there are four people inside the first car. One of them is the driver, the other is the co-pilot. One is sitting behind the driver and the other behind the co-pilot. Well, imagine now that in the second car there are also four people. The driver in the second car would be in the same position as the driver in the first car. The same would happen to the co-pilot and both people in the back. The position of the people in the car represents corresponding angles. One person corresponds to the other person. Let's put this idea into angles. Corresponding angles are in the same position. They are on the corresponding corners. Let's bring back our passengers. So this would be our first car, and this would be our second car. Do you see that the position of each passenger matches? These are the corresponding angles. Now, the beauty of this analogy is that you can imagine your cars going in any direction. Imagine that the cars are actually going north, northeast. Do you see that the girl in the purple jacket with her arms open is now the driver? And the girl in the green V-neck shirt pointing up is now the co-pilot? It does not matter which direction you imagine your cars. The analogy will always work, as long as both cars are going in the same direction. Also, corresponding angles will always be congruent if my double lines are parallel. So before we go to our next activity, let me review what we have learned. Adjacent angles are always side by side. There are two types of adjacent angles who are very important. Complementary, when they add up to 90 degrees, and supplementary, when they add up to 180 degrees. Vertical angles are across from each other and are always congruent. Linear pair angles are always side by side and are always supplementary. Transversal is the line that cuts through two or more lines. Interior region is inside the double lines and exterior region is outside the double lines. Alternate angles are on different sides of the transversal and consecutive angles are on the same side of the transversal. Corresponding angles are on the same corner, as if they were the same people in two different cars.